The engine has several systems which support its operation. The ignition system provides the spark plugs with electricity to fire. The engine drives two magnetos, which are small electric generators dedicated to powering the spark plugs. They continuously power the spark plugs anytime the engine is turning. This design allows a running engine to continue to run even with a complete electrical system failure. Each magneto is capable of operating the entire engine alone. Two are installed for redundancy. Similarly, two spark plugs are installed in each cylinder instead of one. The two magnetos are referred to as the left and right, each firing its own set of spark plugs. If any one spark plug should fail, its cylinder should continue to operate on the remaining spark plug. If either magneto should fail, the other magneto will power its set of spark plugs. As a result, it would take multiple failures in the ignition system to seriously degrade engine performance or cause an engine failure. Because of this redundancy, the failure of an individual component may go unnoticed by the pilot. For this reason, it is important to conduct a pre-flight inspection of the airplane's ignition system in accordance with the procedures recommended by the manufacturer. The ignition switch on a small airplane is operated by turning a key. The switch positions are off, left, right, both, and start. When the switch is in the off position, the ignition system is set to not power the spark plugs. If the propeller is turning with the switch set to the off position, the magnetos will still generate electricity, since they generate electricity anytime the engine is turning. However, this electricity is routed through the switch and into the airplane's airframe, preventing the spark plugs from firing. If the switch or its wiring is damaged, it could result in the spark plugs firing even with the switch in the off position. When the left magneto is selected, the right magneto is turned off by grounding it to the airframe. Similarly, if the right magneto is selected, the left magneto is prevented from firing its set of spark plugs. In the both position, both magnetos are permitted to fire their respective spark plugs. The start position allows the airplane's battery to power the electrical starter. The engine must be lubricated to operate. The oil system on the airplane provides a clean oil supply to the engine. It incorporates an engine-driven oil pump and an oil filter. Most general aviation engines are of the wet sump design, in which the engine oil remains inside the engine case. In a dry sump system, the oil is stored in a separate oil tank away from the engine block. After starting the engine, the oil pressure gauge should be checked to verify the engine is being lubricated properly. Takeoff should not be performed if the oil pressure indication is not in the normal range, since the engine will fail without proper lubrication. Unlike other engine failures, when an engine dies from being ran without oil, it's not going to restart. The oil pressure gauge should be scanned any time the engine is running. An oil temperature gauge is also provided to the pilot. In contrast to the oil pressure, which should come up immediately after or even during the engine start, the oil temperature may take several minutes to come up, especially in cold weather. An engine-driven fuel pump assures that fuel is provided to the engine when the engine is turning. Airplanes often have an electrically powered fuel pump, which is used for engine starting or in the event of an engine-driven fuel pump failure. Alternatively, high-wing airplanes often utilize a gravity feed system to aid the engine-driven fuel pump. Driven by the engine, the generator or alternator provides electrical power to the airplane's electrical system. A generator creates a flow of direct current electricity while an alternator produces alternating current. Alternators are commonly used as they provide more consistent electrical power with varying engine power. An engine-driven vacuum pump supplies suction required for the operation of several flight instruments. While these systems are typical of small training airplanes, systems vary between manufacturers. Many airplanes carry more advanced systems, such as de-ice or pressurization systems. This lesson is intended for familiarization purposes only. Do not attempt to operate any airplane systems until you have been properly instructed in person on their operation by a flight instructor.